Is by Mr. Durk Krone.
Thank the Southeast Bridge Preservation Partnership for allowing us to make this presentation on US190 Mississippi Ridge Rehabilitation Project. Photograph that comes up just now, that's a segment of this major river crossing. It's a 5-span cantilever through truss. That's a portion, that's an aerial photograph of the completed structural rehab plus the paint system for today. One of the unique features about this structure is that it's got a single track rail line down through the center of the truss, and the west and eastbound lanes of US190 cantilever off the north and south face of the trusses. Pretty cool. Our agenda today is describe the design team. We'll talk about, we'll locate the bridge and talk about the history and some of the specifics. We'll then highlight some of the key repairs that we addressed during the design process. And then we'll also do a kind of a deeper dive into those listed repair items there. So show you how we, from the design to the construction, and you can pick up some ideas. And when you have a challenge like this, as we did. Louisiana Department of Transportation and Development, they are the owners. TRC engineers, we were the prime consultant. There were 2 Class 1 railroads that used the rail line, and those 2 individuals were intimately involved from the design on through construction. GPI, they were an integral part of developing the painting notes and interfaced with DOTD to come up with those documents. Vermont and Associates, a DBE subconsultant, they helped us with a number of the structural repairs, and there was a firm at the time named Encon, and they were very instrumental in helping us with evaluating the durations on some of these repairs, as well as helping out with the engineer's estimate. The project, as you see here, is located in the northern industrial area of Baton Rouge. At the time this bridge was built, it was the only crossing for rail and roadway from 160 miles to the north and 80 miles to the south. It's also important to note that at the time there, and still today, there are chemical plants up and down the Mississippi, and at the time the bridge was most likely subjected to the corrosive effects of industrial pollution, especially on the east side of the river. The bridge was built in 1940. It was part of a massive highway program instituted by Louisiana Governor Huey P. Long. He built most of the major bridges in Louisiana prior to the inception of the interstate system. The bridge was named after him. Once the I-10 bridge was built, and was commonly referred to as the old Mississippi River Bridge. 2 rehabilitation projects. It was painted in 1960, in the 1960s, and then there was a major widening project in the 1980s. We were fortunate to be selected for the in-depth inspection in 2005, and then we were equally fortunate to be offered to be contracted to do the rehabilitation design. Project was eventually broken up into 2 phases. We had a set schedule. We had a phone call one day. There were surplus funds available. Can you knock 7 months off your design schedule to deliver phase 1? You know, one of those gifts that you always want to give, because we don't work for money, we work to deliver, right? But in any event, we were able to meet it. Otherwise, I probably wouldn't be standing here. But anyways, phase 1 included the main river crossing, cantilever through truss, plus the combined roadway and railroad structure. Phase 2 was just the railroad portion that included, that added up to approximately 1.2 miles, 12,213 foot long total structure. As you can see here, this is a view looking west with the train traveling down through the center. The trains don't go all that fast, around 20 miles an hour. You can see there are 2 narrow lanes without any shoulders. That's after the widening, obviously, and about 29,000 ADT a day on the bridge. Here's a view of the top of the truss there. You can see that way back when it was painted orange, back in the mid-60s. And why was that? Well, there was an aluminum plant just to the south, and when they would load bauxite from the barges, there was a dust that accumulated on to give it a splotchy, rusty look, so the DOTD gave up and painted it orange. As is common of bridges of this day, is built up sections, plates, angles, and other members, and they are fastened together with rivets, okay? And this here is the The bridge the bridge was slated to be painted in the 1980s, but due to the regulation changes, it was too expensive because they had to fully contain, so the bridge hadn't been painted for close to 75 years. Here you can see the lower chord, the lower portion of the bridge. You can see they have the bottom chords. You have at each bay you have transverse floor beams that are framed into the lower chords, and then you have railroad stringers that support the railroad, obviously, and frame into the center portion of the floor beams. And then you have the cantilever portion for the roadway, and you see the stringers that frame as well into the floor beams. On the approach structures, you can see it's kind of alternating spans of 83 feet and 43 feet between built-up steel towers. Here's on the west bank looking north at the combined roadway and highway approaches. Here you see the list of items that, repair items, obviously with cleaning, painting, disposal. Virtually every component on this bridge at some point had a repair. Substructure was limited to the strengthening of the pedestals and replacement of the bearings of piers 1, 2, steel approach towers, as well as the approach tower anchor bolt and the concrete pedestal retrofit. These are some of the key items that we had to address. Lower lateral bracing, the gusset plates, numerous cracks had to be repaired. The vertical members, you can see here this 100% section loss. They have internal batten plates here that actually accumulated water and debris, and as a result corroded over the years. There was a lot of gusset plates that had fractured in the upper lateral bracing between the railroad girders. Confined space, very difficult to do some repairs. Over the years, you can see the corrosion, and this lower internal mid plate had to be repaired. There's significant pack rust that had to be addressed. 4.27 million square feet of structural steel had to be cleaned and painted. You can see the list of the criteria that was required, everything from washing to abrasive blasting. It was the paint system that went on was a 3-coat organic zinc paint system. The environmental requirements for work out there included, pre and post soil sampling, visible emission testing during when the workers were in the containment, and then also the waste management associated with that. It was red lead-based paint, so it had to have full containment, and you have your OSHA requirements for PPE. Contract documents required that the contractor develop a set of calculations with their shop drawings that prove that under no circumstances would they overstress any of the portion members of the truss. They also had to come up with a procedure that should a named storm hit the coast, the Gulf Coast, they had to drop that containment immediately. Quick view of the approach containment. Well, how do we do with our design collectively, okay? The engineer's estimate came in at $104 million. Phase 1 was awarded to a joint venture of Liberty Alpha. American Bridge was the sub to do the structural repairs, $75 million, and the Phase 2 was awarded to Abbey and Savoda, close to $22 million, and they actually did the structural repairs themselves, as well as the cleaning and painting. Here's a pretty cool picture, is inside the containment of the cantilever through truss over the Mississippi. You can see the contractor set up virtually zones where when they had the curfew, they would at night they would drop their tarps, set up the ventilation, and then come in and do their work. This is one of my favorite pictures. We had, you try and your pride, your clear intent, and you feel real confident, and then you go out there and you see how much containment that the contractor put up, because we didn't envision that happening. But and with Katrina, Rita, Gustav, and all that, it personally made me a little nervous. But I'll tell you, I give you credit to the contractor. He managed it well, and fortunately, we were thankful that no storms came up. Here's a couple the railroad stirrup repairs. Every third to fourth bay, you had a railroad stirrup bearing system for the railroad girders to allow for expansion and contraction. So here you take the deck off, and you can see the railroad girders framing into the stirrup bearings, as they're referred to sometimes. Some people call them saddle bearings. There you see a picture of them. Had to disassemble them to look at the pieces to see if they needed to be replaced. So we developed two jacking systems. And we allowed the contractor, if they came up with a better idea, to utilize their system. We thought we were pretty smart, though, and you'll see what happened, though. We also, working with the railroad, they says, okay, we can only allow you 10 hours for curfews. To the contractor's credit and DOTD's coordination with the railroad during construction, they were allowed to go up to 12 to 14 hours, and that really helped them out a lot. We weren't smart enough, okay? Contractor came up with a better idea. They used a jacking system above, and you can see below the workers are getting ready to disassemble the members. Just to do it rendering, this main stirrup strap floor beam connection, that was one of the major items of concern, of deterioration, as well as the stirrup straps, and also these bearings, these semicircular castings. They have been in place for 75 years. So what we did was the contractor would order a few in advance, and when they found out they had to be replaced because they're so costly, you had to cast them and all that, they had them on as an inventory product. Here you can see the getting ready to start removal of some of the members, and there you see that in between full replacement, and lo and behold, they have a completed member there, okay? I want to try and keep moving, but there, take another look. In any event, lower laterals of the tower bents, major corrosion, pack rust, deterioration. Here you see a repair, partial member repair. And here you see up a partial repair of a gusset plate. If you look at that upper right corner there, there's a clipped angle from the pack rust. And another cool picture, I'd like to go in there and just, you feel like you're in a tent, and there you see the repairs. This was the anchor bolts here. You see a tower leg with the anchor bolt and the pedestal, okay? This was a major issue because there were so many anchor bolts that were highly deteriorated. And so we came up with two repair types on the project. You can see here that the majority of these anchor bolts were like 50 to 70% deteriorated, and you can see some of them are 100% section loss. You can virtually remove them. So what do we do with one of the areas? When you had area to excavate, enough room, we developed a totally independent new system to where we actually added new concrete, anchor bolts, and then we came up with a structural beam system that wrapped around the and tied into the actual tower legs. And here you see it completed right there, and you see how it's anchored right into the lower leg. Now, for the phase one, you can see, if you look down, you can see the edge of the roadway. Well, how do you excavate, do that similar repair? Well, what we had on our contract drawings, the intent was, okay, remove the concrete by hydroblasting or, some sort of striking a line, and then use some demolition products, and then you cut off the anchor bolt, put in a splice, and there you go. Oh, but you have to come in with some higher early strength, non-shrink grout as a result. One of the challenges one day we had to meet with a contractor, and I won't go into the complete drama, but there was issues with regard to them removing removing rivets on the main truss. That had absolutely no problem on the approach trusses. But what's that issue? And in the future, I think if one of the lessons learned is not that the DOTD had to pay any extra or anything. Don't get me wrong. But there's a camming effect when you have multiple plates that aren't in line and you drive that rivet in there, and it actually takes the form of those plates. So when the contractor, what does he want to do? He wants to come in and knock the top of that rivet out, and he wants to take a spike with a hammer and just drive it out. Can't do it. You have to, one method is you have to drill in and then hammer it out, and it'll collapse on itself. But think about the time. And when you're estimating $30 per rivet, that's not going to get you far. Just for the future. That's the pedestals. There were during the widening on piers 1 and 6, they extended obviously the pedestal out, and a vertical crack appeared early on. This was in about 1988. It was opened, and those cracks appeared in the 1989 inspection report. So that's one of the incredible values of an inspection process, is that, and you look at the bottom there, the concrete, there's kind of like popping, and you can see that you've got some loose concrete there from spall and all that. But that had not changed much since the late 1980s. This spall here underneath, that's a new bearing actually. But DOTD, to their credit, they put a monitoring system on just to make sure there wasn't some adverse movement. Is that right, David? Yeah. Right? And so how do we repair it? Okay, we want to strengthen it. So we actually came in, knocked out the loose concrete, and then the contractor, injected grout and used cementitious necessary grout to get you a smooth surface, and then they installed fiber reinforced polymer, okay? Carbon fiber reinforced polymer, fiber wrap, okay? What was unique here is that contractor got done, and then we get that phone call. Oh my goodness, it's cracked. And you know, what did we do wrong, you know? And what we did was we partnered, you know, we came together, we says, what went on, okay? And then we looked deeply into it. There was a lot of drama. I'll just be honest with you, a lot of drama. But basically what the contractor did was they submitted a shop drawing, and this was a subcontractor. I'm not blaming the prime here. This was a subcontractor. And what happened was they submitted a unidirectional fiber wrap system, and our contract documents called for bidirectional. Well, what they did was they installed the unidirectional in the weak axis over the crack, so it cracked. So there was a lot of issue, and then we eventually worked together with our sub, and we put together a report, include a finite element analysis, and says, hey, if you put it on right, we think it'll work. And so now you're saying, okay, when we were out there, we saw localized areas where the fiber wasn't fully attached, but overall they did do some testing, pull-out testing, and the fiber wrap was attached properly from the standpoint of pull-out. Well, contractor eventually went out and installed it. I don't see a crack today, okay? I didn't go out there this morning, but from it's one time, you know, as a designer, he says, gosh, you know, okay, you know, we've made it. But hopefully it'll stay that way for the next 30 or 40 years.
Dirk, you had an interesting detail there of the anchor bolt replacement where you had chipped out and actually replaced the anchor bolt in the pedestal. I sensed as you were saying it, though, that was maybe the original detail. Was there a change to that detail through the construction? Did that not work? It looked good to me.
We actually developed two details during the design phase. So I may have said something, may have alluded to something, but no, it was there was no change to the original design. We had it there. In other words, the contractor didn't come up with a value engineering or some sort of alternative. We had the two all along. So.
Ultimately, what you had in the picture there, that worked out. That was a good detail.
That did work out, and actually the contractor did a very good job. They were very, at least the ones that we were saw, and I want to give a shout out to Majeski Masters. They were the CE&I representative out there during construction. So with DOTD, Majeski Masters, we had a good partnership out there.
Great presentation.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.